In this, we are going to review the constant coefficient linear homogeneous differential equation. And we also solve 11 different examples at the end. So before we start further, let's see what we mean by a constant coefficient linear homogeneous equation. So such equation can be written in this form. So we have an y to the nth derivative plus an minus 1 y to the n minus 1 derivative, like that. And you can see these an and an minus 1, a1, a0, they are all numbers. They are all constants. And then you can see that there's a 0, that means it is homogeneous. And there are no product of y or derivatives, so this is linear. So this is a constant coefficient, linear homogeneous. Okay, so let's look at the special case. So what we can do, we can look at the special case when n equal 2. So when n equal 2, this is going to be quadratic. So we normally write the quadratic case like this. So a y double prime plus b y prime plus cy equals 0. So that's the form we're going to consider. And let's call this equation star. So we can refer this to this equation later. So what we can do, normally when we solve a problem like that, what we do, we assume a solution of a special type. So we can assume a solution of the form y equal e to the lambda x. So, so let's write it. So assume a solution of the form y equal e to the lambda x. Lambda is a constant that we are going to find. So what we normally do is we can take derivatives. So taking derivatives, so taking derivatives, so we can say, so if you take derivatives, you're going to see y prime, that's the first derivative. By the chain rule, this is an exponential function. So what will happen is this lambda, the constant, going to come out. So that means the first derivative is lambda, e lambda x. And similarly, if you take one more derivative, so y double prime, which is, you get another lambda. So it will be lambda squared e to the lambda x. So those are the derivatives. Now what we can do, we can substitute this into the equation. So let's do that now. So we substitute. So you can say substitute into the equation star. So if you do that, what will happen is it is a times the second derivative, which is lambda squared e lambda x, and then plus b, the first derivative, which is lambda e lambda x, and plus c, this is just a function itself, which is e lambda x. So now what you want to do is find the lambda. But before we find lambda, we notice that e to the lambda x is appearing everywhere as a factor. So we can take it out. So if we take that out, lambda x, so what will happen is you get a lambda squared plus b lambda plus c equals 0. That's what you get if you pull lambda e to the lambda x out. But you know that e to the lambda x can never be 0. So that we know. So since e to the lambda x not equal to 0, so only possible thing that can happen here is a lambda squared plus b lambda plus c becomes 0. So that is the only possible situation. And so this is what we get. So that is the equation that lambda need to satisfy in this situation. And we assume that a not equal to 0, because if a equals 0, this is not quadratic anymore. So this equation even has a name. We normally call this equation a characteristic equation, or sometimes we also call this an auxiliary equation. So this is called the characteristic equation. Characteristic equation. Or sometimes we call sometimes we call auxiliary equation. But I would like to call this a characteristic equation. The reason is this is going to characterize the form of the solution, so it's much better to say it characteristic equation. Okay, so let's consider, so you can see this is a quadratic equation. That means there are three cases depending on the discriminant. So we're gonna look at the case by case quickly. So there are three cases. So we use the quadratic formula to find lambda. So the equation is a lambda squared plus b lambda plus c equals 0. This is a quadratic formula, and we assume that a not equals 0. Otherwise, it's not going to be quadratic. And the quadratic formula is, so simply lambda, which is going to be negative b plus or minus b squared minus 4ac square root, and the whole thing divided by 2 times a. Since you divide, you assume that a not equal to 0. And then you can see that, so there's a discriminant part that's going to decide what will happen to the solution. So that's why this called the characteristic equation. The sign of b squared minus 4ac is going to tell you what will happen. It can be positive, 0, or negative. So those are the three cases we have. So we have uh, two distinct solutions, repeated solution, and complex solutions. So depending on the situation, so we have so two are real distinct from the first case, and then real repeated solutions, and then the negative case you get complex conjugate solutions. So complex conjugate solutions. Those are three cases. So let's look at one by one. So there are three cases. So let's look at the case 1. So the case 1 is, so we can simply look at the discriminant, so which is b squared minus 4ac. So this can be positive. That's the first case. So in this case, what will happen is, because this is like quadratic equation, so there are two distinct real solutions. So there are two distinct real solutions. There are two distinct real solutions. So let's say they are lambda 1 and lambda 2. So if you know that they are lambda 1, lambda 2, now we can write the general solution, because we know that the solution has the form e to the lambda x. So, and these are the lambda values. So we can write it. So the general solution of star is, so the general solution of star, that's the major equation, is simply, if you take the t as the variables, you can see it is yt equal c1. Let's say actually yx, because like x is the most common one we use. So yx, so which is which is c1 times just a number, c1 is just a number, e to the lambda 1x plus c2 e to the lambda 2x. So that is the solution. That is the solution for the case 1. So let's see. So we are c1 and c2 are constants. c1, c2 are constants. c1 and c2 are what we normally call arbitrary constants. Arbitrary constants. Good. So let's look at the case 2. So case 2. So what happened in case 2 is, so you can see the discriminant is 0. That's the second case. So we have b squared minus 4ac equals 0. In that case, what will happen? There are no plus or minus case, because the discriminant, the square root part is 0. So in this case, what will happen? We have repeated real solutions. Last time what happened? Two distinct real solutions. In this case, what happened? Repeated real solutions. So we're going to call them lambda, just call them lambda, which is simply, if you look at the quadratic formula, it coming from the first part of the quadratic formula. That means it is simply going to be negative b over 2a. So that is the solution. And it can repeat because there's no square root part anymore. So that means you can write the general solution. So the general solution in this case, so the general solution is simply going to be y x So what happened is, first solution you can write as it's the same thing from before. So C1 E, I'm just going to call lambda x. Now what happened? You cannot repeat the same solution because there's no point writing the same thing again. So what will happen using the reduction formula that we discussed earlier? It can give you a different solution. What's the next solution is you simply multiply the first solution by the independent variable. So that means it is going to be C2 x e to the lambda x. So that is the second solution. So only thing what we did is we just multiply by a x to get another linearly independent solution. So that's a new solution. So that is the general solution for this case. So this is what you need to remember. So what happened? Just multiply by an extra x. So multiply by an extra. So remember like that. It's gonna help you later when you do the undetermined coefficient method by an extra x. So remember like the extra x. Don't just remember this as a multiply by an x. You multiply by an extra x. I will tell you why you have to remember it like that. Okay, so so let's look at the third case. So the case 3, which is b squared minus 4ac, which is negative. So in this case, what will happen? You get complex conjugate solutions. Complex conjugate solutions. And then what we do once we solve, you get lambda, which you can represent as alpha plus or minus, those are two conjugate solutions, beta I. That's what you get. So I is the complex unit. So we have I squared equal -1. So what we do, we just use the same formula as in case 1. So what will happen? We write y, which is equal to C1e, and this is the first solution. So which you can write as alpha plus beta I times x as a first solution, and then the second solution C2e alpha minus beta I. That's the second solution, and x. So then what we do is you can pull out e to the alpha x. You can pull this term out as common. So if you do that, you can write this one as e to the alpha x. That part is common. Write the rest. So you can get c1 e. You can say beta x I. That's the first one from the first one. Plus the second one you say c2 e minus beta xi. So after you pull out e to the alpha, you can write it like that. Now what we can do is you can use the Euler's identity to rewrite these two in a nice form. So what we normally do is we can write this one as e to the alpha x. X is the independent variable, and then you can write these two using Euler's formula. You simply write it like this. You can say write this one as a cosine beta x plus b sine beta x. That's the final form. And then where you get this one from? It's simply coming from the Euler's identity. So so we can write this as a knot. And if you do not remember this one, you can look at the main video about this topic, and that explains how all the steps and where you get this one from. So Euler identity is e to the I theta. So this is simply equals to cosine theta plus I sine theta. This is what we normally call the Euler's identity, Euler's formula. So Euler's formula or Euler's identity. And there's something called Euler's equation. That's something else. It's a special case of this one. It's Euler's formula. Okay. And then also you can use the same argument. Those are the three cases. So that's the third case. So so let's highlight. So that's the third case. That's what you need to remember as a third option when the roots are complex. And then also this can be used for higher order differential equation as well. So these three techniques can be used for higher order differential equation as well. So, and we're gonna do some problems at the end also. Then you will see that yes, it can work. And also, why we need to only consider this case? Because you remember in algebra, there was a theorem that says that if you have any polynomial, you can write it as a product of linear or quadratic factors. So we had that theorem from algebra. If you have any polynomial, you can write it as a product of linear or quadratic factors. That is the reason why we only need to consider this quadratic case as the highest case. Um, so, and then you can do all the other problems using these two. Okay, so let's look at several problems just to see how this is gonna work. So find the general solution. Find the general solution of the following equation. So we know that there are three cases. So let's go one by one. Let's say the first example. So we have y double prime minus y prime minus 2y equals 0. So what we can do, we can look at the characteristic equation. So which is how to get the characteristic equation. What we do, we're gonna replace all those powers by lambda powers. So that means going to be lambda squared minus lambda, and there is no derivatives. All the derivatives going to be lambda powers, but there's no derivatives, so it's just going to be 2. That's what you get, equals 0. So that is the characteristic equation, and you know that this is very easy to factor. So the factors are lambda minus 2 and lambda plus 1 equals, and if you don't know how to factor like things like that, you can look at a video about factoring polynomials, and you can find the link in the description. So there are easy ways to do these kind of things. Okay, so the two numbers you're going to get is lambda equal 2 from this one and lambda equal negative 1 from this one. What we do, we set the factors equal to 0 and you get those two zeros, and then we can declare the general solution. So the general solution is, if you assume x is the independent variable, so yx is, it's not given, so it is c1 e to the, we normally have the smaller one first, so lambda is negative 1, so negative 1 x, so you can write like that, and then plus c2 e to the 2x. So that is the solution. That's a general solution where you have two unknown c1 and c2. You can find the c1 and c2 using initial conditions. Okay, so that we don't know, let's find c1 and c2 using initial conditions. So let's see how we can solve this problem if c1 and c2 the initial conditions are given. So let's look at that quickly. So if it is given that y0 equals 0 and y prime 0 equal negative 6, find c1 and c2. So what we do, we have the equation. So yx equals c1 e to the negative x plus c2 e to the 2x. So what we first do is we take the derivative, because you know the derivative here. So you can see if you take the derivative by the chain rule, you have to multiply by these numbers. So that means it is going to be negative c1 e to the negative x plus 2c2 e to the 2x. So now what we're going to do, we're going to use the initial conditions. So using the initial condition, so we can write y0 equals 0 going to give you, if you plug in, so we could c1 e to the 0, so you plug in 0 area, so it is c2 e to the 0, which is equal to 0. That's the condition given, and this says that c1 plus c2 equals 0. So I'm going to call this equation number 1. And then let's look at the other conditions, which says that y prime 0 equal negative 6. So if you use that, you can see that negative c1 e to the 0 plus 2 c2 e to the 0 equal negative 6. This says that negative c1 plus 2c2 equal negative 6. Now the easiest way to solve these two equations, you can see these two have different coefficients, like an opposite sign. That means if you add them, you're going to get c2. So that's the easiest way to solve this one. So I'm going to add them and find c2, and then use equation number 1 to find c1. So let's do that. So adding, you get 3c2 equal negative 6. This tells you that c2 equal negative 6 over 3, which is negative 2. And then by 1, you can say c1, which is negative c2. According to that means it is 2. So that's going to give you C1 and C2. So we're going to plug in those two and write the solutions to the initial value problem. Therefore, the solution to the initial value problem, these are initial value problems, y double prime minus y prime minus 2y equals 0, y0 equals 0, and y prime 0 equal negative 6 is, so you can write this one as, finally substituting the value, you can say yx equal to e to the negative x negative to e to the 2x, and you can see this solution is valid on negative infinity to infinity, so that's the domain. Okay, that's how we solve like a complete problem. But for the rest of the problems, we are not going to do all of them. We only write the just the general solution, just to save time, because we want to go through different type of problems. So let's look at the next one. So as the next one, we have y triple prime minus y double prime minus 2y prime equals 0. So this is a higher order differential equation. This is not second order, or this is not the first order. It's like a third order. So we do the same thing. So we write the characteristic equation, so which is going to be lambda cube minus lambda squared minus 2 lambda equals 0. The derivative convert to powers. The derivatives convert to powers of lambda. Okay, now the goal is to factor this, and it's very clear that lambda is a factor, so we're going to pull this out. So if you pull this out, you're going to get lambda squared minus lambda minus 2, and you can see the second factor is exactly the same factor as before. That means we can write this one as lambda minus 2 and then lambda plus 1 from previous one. So that means the solutions are simply, so the lambdas, so you can write the solutions of this one. So the solutions are lambda equal, so we have 0 from the first one, and 2 from the second one, and negative 1 from the third one. So those are the three solutions that you can write the general solution. So the general solution you can write as, let's say t is the independent variable, so it's yt, which is c1 e to the 0 t, the first term, plus, and then c2 e to the, let's write the negative one first, next, so negative t, plus, and then c3 e to the 2t. Those are three solutions. So and then you can see that this can simplify c1, you get a constant, plus c2 e to the negative t plus c3 e to the 2t as the solution. So you can see it's not that difficult, it's just very straightforward. So we do the exact same thing as before, but only thing is we have three solutions now. Since we have three solutions, you get three different terms. Okay, so let's look at the next one. So suppose we have y double prime plus 2y prime plus y equals 0. So as before, so we can write the characteristic equation. So it's going to be lambda squared plus 2 lambda plus 1 equals 0. So that's a characteristic equation. And if you know from algebra, this is simply lambda plus 1 squared equals 0. Because you see lambda plus 1, lambda plus 1, that's what you get. And this says that lambda equal negative 1 and negative 1. So that is going to repeat. So that's the idea. But if you forget that, what we can do is you can just use the quadratic formula. It always works. So let's say lambda, if you use the quadratic formula, which is negative of the middle term, so negative b plus or minus, and then you square the middle term coefficient, so it's going to be 4 minus 4ac, those are 1, so that's what you get, and divided by 2 times a, which is 2. And then you can see since the middle term is 0, so you can see this is going to go with 0, so you only get negative 1. So and then we write this term negative 1, negative 1, little exaggeration just to say that is repeat. So we do that, so repeat. Because of the repetition, this is the case number 2. So that means your solution is simply going to be yx. If you say x is independent variable, which is c1 e to the lambda x. Lambda is, so the solution is what? Lambda x plus c2 x e lambda x. That's the solution. So if you plug in here, you can see that this is c1 e to the negative x plus c2 x e to the negative x as the second linear independent solution. And then again, this also valid on negative infinity to infinity. Okay, so that's the general solution with just two unknown. Let's look at the next one. So as the next one, we have y double prime plus y prime plus y equals 0. It's a very interesting equation. All the coefficients are 1. So let's look at this one. So it's a characteristic equation. Characteristic equation is lambda squared plus lambda plus 1 equals 0. There's a 1 here because there's no derivative of the last term. We just get a coefficient 1. Okay. Now, so you can see that this is not easy to factor. So not easy to factor. So since that is the case, we just use the quadratic formula. So if you use the formula, which is lambda equal negative 1 plus or minus 1 squared minus 4ac, which is 4 square root over 2a, which is 2. So if you simplify this a little bit, you get negative 1 plus or minus negative 3 square root. And then again from algebra, we know that how we write this one. What we normally do is we can write this one negative 1 plus or minus. We can write this one as 3i squared because I squared is negative 1. And then like simply take the factors like as we normally would do. So it's negative 1 plus or minus square root 3. I is outside over 2, and then we can separate them. So if you separate them, you can write this as negative 1 half plus or minus square root 3 over 2i. So that's going to give you two terms. That's the alpha term, and this is the beta term. So so we can write them. So we can write as alpha equal negative 1 half, the beta equal square root 3 over 2. So those are the two terms that we get, alpha and beta. Now what we can do, we can plug in that to the solution. So let's write the form now. So we have yx. If you remember the formula, it is going to be e to the alpha x times, we have a cosine beta x plus b sine beta x. So if you plug in here, so you're going to get e to the alpha equal negative 1 half x is the independent variable, and then a cosine square root 3 over 2x plus b sine square root 3 over 2x. So that is the solution. That's a general solution where a and b are arbitrary constants. So you can see there's something interesting going on. I'm going to tell you something about this one, and then you can see this part actually going to 0. This we normally call the envelope of the function. It's going to envelope. And you can see the second part, which is a sine and cosine linear combination. That means you can represent this just as a one sine or one cosine. That means this is going to oscillate. So this is oscillating part. So this is going to oscillate. The oscillating part, and this is the envelope part. That's going to give the amplitude. So that means if you look at the graph of this one, it's really interesting. This is what happened. So this is x and the yx. So what happened? This gonna go envelope between. So this is we have this envelope part. That's amplitude. It's gonna go like that, and the same thing on the other side. It's gonna go like this. It's gonna go smaller and smaller and smaller. So, and this part is coming from that. So this is simply e to the negative 1 half x part, and the bottom part is simply the negative of e to the negative 1 half x. That's going to give you the amplitude, and then inside that you're going to get the graph. So it's going to go like this. Just go like that. Just keep the period, but just going to go smaller and smaller and smaller and diminish. So that is the situation of this one. This is a very, very interesting one. So for example, this can happen if you have a, let's say like if you hang a mass from a spring, and then if you give like a little push to the top, so it's going to go top up and down. And if you look at the graph, that's the graph you're going to get. So it's going to go like high, and then it's going to go smaller, 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 and then stop. So that's what happened. So that is the situation you are talking about. So and this is the equation from that. Okay, so let's look at the next example. So all the types are over, but we can do like a couple of more examples just to master the idea. We just do like few different examples. So let's look at the next one. So we have 2x double prime minus 5x prime minus 3x equals 0. So now x is the so in this one you can see x is the dependent variable. So x is the dependent variable. So we can assume t as the independent variable. So you have to decide that before we write it. Okay, so steps are all the same. So what we can do, we can write the characteristic equation as before. So if you write the characteristic equation, you're going to get 2 lambda squared minus 5 lambda minus 3 equals 0. Now we need to know how to factor this one. So next step is a factoring step. So I'm going to do this in my way. So we're going to multiply the two numbers. So you're going to get negative 6. And then think about how to get the middle term. From negative 6, very easy. You can get the middle term by negative 6 and 1. Negative 6 and 1, those are the middle term. And then think of the factors of 2, which is 2 and 1. So we put the 2 here and the 1 there. So that's going to give you the factorization. So the factors are simply 2 lambda, go with 1, and then lambda go with negative 3. So that's, you just write this one as a crisscross argument like that. So it's going to give you the factorization. This is equal to 0. And then you can see the first term going to give you lambda equal negative 1/2. The other term going to give you lambda equal 3. So that means your solution is xt equal c1 e negative 1/2 t plus c2 e 3t. So that is the solution of the problem. So let's look at the next one. So we have this interesting problem. 2x triple prime plus 3x double prime equal 5x. This looks slightly different. So what we do first is we're going to move this term to the other side first. So that's the first step. So we can write this one as 2x triple prime plus 3x double prime minus 5x equals 0. That's the first step. Move everything to one side. Now we write everything else is the same after that. So we can write the characteristic equation. So which is going to be 2 lambda cube plus 3 lambda squared minus 5 equals 0. And only next step is how to factor this one. And you see that there's no lambda term for the last one because there's no derivative. Okay, so now what we do, the question is, this is a cubic equation. So how to find factors of a cubic equation? So when you have higher order polynomials, what we normally do is we try to use the factor theorem. So factor theorem is one of the good tool to use in situations like that, because if you know quadratic, we can directly go to the quadratic formula and we can factor or use the quadratic formula. But when you have cubic or higher degrees, what we need to do, we need to first try to find the first few. So what we normally do, we use the factor theorem. So what the factor theorem is, you try to guess the solution. So that's the idea. Try to guess. So what we normally do, try these values. So we're going to try 0, plus or minus 1, and plus or minus 2. So that's what we normally do in an exam or a quiz. Like when you have, we try those small values because we don't know other random values. You never try like 2/3 or something. who knows? I mean, you can use them using the rational rules theorem, but we don't go that far. So try these small values. So you can see if you plug in 1, actually it's going to work. So you can see, so what we do is we can say lambda equal 1 is a solution. Okay, so lambda equal 1 is a solution. So by the factor theorem, by the factor theorem, so what the factor theorem says, if you know a solution, then when you subtract that value, it is a factor. That means lambda minus 1 is a factor. So it says that by the factor theorem, you can see that the lambda minus 1 is a factor. So now the question is how to find the other factor. So to find the other factor, what we can do, we can use the synthetic division or the lone division. So we use synthetic or the long division. So whatever you are comfortable with. But here I'm going to use a synthetic division because it's much quicker. So let's do that. So I'm going to use a synthetic division for this problem. So here we use the factor theorem and the synthetic division. So how we use the synthetic division? We first write all the coefficients. And if you see that there's a coefficient is missing, don't forget to put a 0 for that. So that means you can write this one as, if you write the coefficients, it is 2, that's the first one, and 3, that's the second one. There's no coefficient for lambda, so that means we're going to put a 0 for that. There's no lambda term, and then minus 5. So those are the coefficients. And then we use this symbol, just like a symbol we use for a synthetic division, and then we put the 0 here. We have to be very careful. That's a 0. So we put the 0. Now what we do, we copy this number down and then multiply and add. So you're going to multiply always with 1 and then add here. That's what we do. So that means when you multiply you get 2, so you put it there and then add them. So you get 5 and keep doing. Then you multiply 1 and 5 and add, you get 5. Now you can add that here, so you can put, so you get 1 times 5, which is 5, so put it there. And then when you add, you can see that you get a 0. That's a good sign. That means when you get a 0, that means 1 is a 0. So and then the factor, this is going to give you the other factors. These are the coefficient of the other factor. So that means the other factor is, simply 2 lambda squared plus 5 lambda plus 5 equals 0. Now we use the quadratic formula to find the, because if it is easy to find factors, it's okay, but you can see that's not easy to find factors, the zeros. So what we're going to do, we can use the quadratic formula to find the other one. So we already know 1 is 1, but we can use the quadratic formula to find the others. So let's do that. So we have 2 lambda squared plus 5 lambda plus 5 equals 0. So if you use the quadratic formula, you can see that lambda equal negative 5 plus or minus 5 squared, that means 25, minus 4 times a equal to c equal 5 square root and divided by 2 times a, which is 4. And if you simplify, you can see that this is simply going to be negative 5 plus or minus, you get 15, negative 15. So this is negative 15 square root over 4. And if you find the solution, you get negative 5 over 4 plus or minus square root 15 over 4i. That's what you get. And then you can see that this alpha equal negative 5/4 and beta equal square root 15 over 4. So if you plug in them, you can see the general solution is xt equal, you see that lambda equal 1 is solution. So you could see 1 e to the t, that's the first term, plus, now from this one you get the complex solution like this, e to the negative 5/4 t times you get C2 cosine square root 15 over 4t plus C3 sine square root 15 over 4t. So that is the general solution with three unknown coefficients. So there are three unknown coefficients like that. Okay, so so that's the idea. And then some you can see when time goes, actually this term going to disappear because of the first term. So this is, we normally call this is a transient term. Transient term. So transient terms is a term with a negative power. So because that's going to disappear as time goes, and then the other term going to dominate the system or the whatever the moving object. Okay, so I mean those are the like kind of major cases. So we can do a few more examples just to master, but otherwise the theory is over. I'll just do a couple of more examples just to learn a few more. Okay, so let's look at a few more examples quickly. Suppose we have y double prime equal negative 4y. So that what this means is the second derivative is proportional to y. So in this case, what we're going to do is, this is a very common problem. This is one of the very common problem. What we normally do, we're going to move all the terms to one side like that. And then it's like a general problem. So we can look at the characteristic equation. So it is going to be lambda squared plus 4 equals 0. That's going to give you lambda equal plus or minus 2i. You can write this one as 0 plus or minus 2i. So that means there's no alpha term. Alpha term is 0. So the alpha equal 0, beta equal 2. So that means you can write the general solution, which is yt equal c1 cosine 2t, that's the beta, plus c2 sine 2t. So this is a very common problem, and this is what we normally call the simple harmonic motion. That's what we normally call simple harmonic motion. Okay, so let's look at the other case. So the next one. So let's say we have y double prime equal 4y. Now it's a positive term. So when you have positive term, what will happen is y double prime, you're going to bring this one to the other side. So 4y equals 0. So similar steps. So the characteristic equation. So it's going to be lambda squared minus 4 equals 0. Now this is real actually. So you get real. So it is lambda equal, you can see plus or minus 2 are the solutions. So that means the yt you can write using the first case. So it's going to be c1 e 2t plus c2 e negative 2t. So that is the solution. But in this case, actually, we are not going to write it like this. This is normally what we call a hybrid model. These are what we exponential growth and exponential decay situation. So this is exponential growth case, this is exponential decay situation. It's what we normally call hybrid model. Hybrid model. So hybrid model. So what we normally do, we don't like that. We use hyperbolic functions to write this one. So using hyperbolic functions, we know that they're using a cos, hyperbolic cosine. Cos, in this case 2t is simply going to be e to the 2t plus e to the minus 2t over 2. That's the hyperbolic cos. And hyperbolic sine, what we know called sin 2t, is just with the negative sign. So it is e to the 2t minus 2t over 2. So that's the hyperbolic sign. So you can see something interesting happen. If you add them together, you can see the negative term going to cancel out. You can get an expression for e to the 2t. So e to the 2t is simply going to be cos 2t plus sine 2t. So it is cos 2t plus sin 2t. That's what happens when you add them. You can see when you add them, the negative term going to cancel out. Now what we do, we can subtract. When you subtract, the first term going to cancel out. So that means e to the negative 2t is going to be cos 2t minus sin 2t. Now what we can do, actually we can substitute that into the expression that we get, and then you can write the whole thing just using sine cosine now. So that means the most common way to write this one is like this. So we write this one as yt equal a cos 2t plus b sin 2t. So that is the most common way to write it. So remember this is the algebra part. So we are a and b are combination of c1 and c2. Okay, so let's look at the next one. So it's also a very common situation. Suppose we have y triple prime plus y equals 0. I mean, just another example. So, and you can see the characteristic equation is simply lambda 3 plus 1 equals 0. So the goal is to find the factors, and we know this one. This is the cubic sum of cubes. So the factors are lambda plus 1, and the other factor is lambda squared minus lambda plus 1. So this is like something we learn in algebra. But let's say you may wonder where you get this one from. You can use a simple division to get that coefficients. For example, if you have the coefficients, you can see it is 1, no lambda squared, no lambda term, and there's a constant term. And then we know that -1 is a solution, or 0. So then use a simple division, you can see this is 1, and when you multiply you get -1, when you add you get -1, and when you multiply you get 1, and when you add you get 1, and -1 1 going to give you -1, so which is 0. That means that's right, and this is going to give you the coefficient, and you can see that's exactly the coefficients of this term. So that's the other way to get the second term. Okay, so let's see what are the solutions now. And you can see the first one going to give you the solution lambda equal -1. And then if you look at the second one, you can use the quadratic formula for the second one. So which is negative b, which is 1, plus or minus -1 is squared, which is 1, minus 4 a and c. So square root divided by 2a, which is 2. So, and if you simplify, you can see this is simply 1 plus or minus, and if you simplify under the square root, which is -3, so that means square root 3i over 2. So that means you get alpha equal 1/2, so alpha equal 1/2, and the beta equal square root 3 over 2. So that means the yt is simply going to be c1 e to the negative t, that's a transient term, plus you get, so the second term is e to the 1/2 t, and then we have c2 cosine square root 3 over 2 t plus c3 sine square root 3 over 2t. So that is the solution for this problem. So let's look at another one. So let's say we have y to the fourth derivative, y of the fourth derivative plus y double prime equals 0. And as before, we can write the characteristic equation, so which is going to be lambda to the fourth power plus lambda squared equals 0. And you can see lambda squared is a common factor, and then you're going to get lambda squared plus 1 equals 0. And the first one going to give you lambda equals 0 as a repeated 0, we write it like that. And the second one going to give you lambda equal plus or minus I. So which we can write as 0 plus or minus I, or 1i if you want to exaggerate that. And so the alpha equals 0 and the beta equal 1. So if you plug in that, so you can see this is yt equal c1 e to the 0t plus c2. So you can see this is a repeated solution. When you repeat the solution, what we do, we normally multiply by the independent term, independent variable. So that means it's t e to the 0t, and then plus e to the 0t And then we have few more. So we have C3 cosine t plus C4 sine t. So that's what you get. And then if you simplify, you see the 0t is simply 1. That means you can write this one as C1 plus C2t and then plus the other terms. So you get C3 cosine t and then C4 sine t. So that is the solution of the general solution of the differential equation, which has 4 unknown, and it's clear because it's a fourth order differential equation. So there should be 4. Okay, so let's look at one more, like little complicated one, like maybe like fifth order differential equation, just to see how things can go. So let's look at that one. Suppose we have this scary looking equation, 6y to the fifth derivative minus 13y to the fourth derivative plus 6y to the third derivative plus 3y double prime minus 2y prime equals 0. So steps are exactly the same. So we can look at the characteristic equation. So if you look at the characteristic equation, you can see that this is 6 lambda to the fifth power plus minus 13 lambda to the fourth power plus 6 lambda to the cube and 3 lambda squared, not y, lambda squared, and then minus 2 lambda equals 0. That's what you get. And then you can see lambda is common. So if you can pull out, you can get 6 lambda to the fourth equals 0. So that's what you get. Now what we do, how we normally do this, like a fourth order polynomial. If you want to factor, what we normally do, we try those easy values. So we're going to try, as we discussed earlier, 0 plus or minus 1 plus or minus 2. So we can try those values in that order. So, and then you can clearly see that by inspection, and you can see that lambda equal 1 is a solution, is a 0 or is a solution. So that means for the rest of the terms, we can use the synthetic division to find the rest, because you only need to find 3 more, because once you find 3 more, you get a quadratic equation and you can factor the quadratic and find it. So let's try to find 2 more. So let's start with the coefficient. So it is 1, negative 13, 6, 3, negative 2. So we write it and put the 0 here and copy 6 down and multiply and add. So you get a 6, which is negative 13, or negative 7, negative 7, and then negative 7. So it's going to give you negative 1, and then negative 1, which is going to give you 2, and then this is 2, which is going to give you 0. That means that's right, that step is right. And then we do what we normally do, we check 1 again, because 1 can be a multiple repeat or repeated solution. So let's check that again, whether 1 is a solution again. So that's like we should have to do that. And if not, then we try negative 1. So you get 6, and when you multiply, you get 6, which is negative 1. And when you multiply, it is negative 1, so which is negative 2. When you multiply, you get negative 2, and which is a 0. Yes, that's also a solution. And that's it. We don't need more, because this is going to give you the quadratic factor, and those are the coefficients. So let's write it now. So we have 6 lambda squared minus lambda minus 2 equals 0 as the other factor. And then we're going to find a factorization, and you can see you can multiply the two numbers, which is negative 12, and to get the middle term, you can see this is negative 4 and 3, and the factors of 6 that divide these two numbers are 2 and 3. So 2 and 3. So we write 3 here and the 2 there. So that means your factorization is 2 lambda, go with 1, and then 3 lambda, go with negative 2. So that is the factorization. You directly get that factorization using the crisscross argument. Okay. The bottom term going to be the coefficient, the fraction going to give you the other term on the other side. Okay, so that's it. And then this is going to give you the lambda value. So lambda equal negative 1/2. And then the other one says lambda equal 2/3. So that means the solutions are, so all the solutions. So solutions are, you can see lambda, first it is a 0. And then we had 1 as repeated solutions, and then negative 1/2 and 3/2, 2/3, 2/3. So these are all the solutions. So that means we can write the final solution as, so the general solution, general solution is this. We have yt equals c1 plus c2 et, c3 tet because of the repetition of 1, and then the other two terms. So that is the general solution which has 5 unknown. Okay, so let's look at one last problem. We have y double prime minus y prime minus 2 equals 0. So there is a major problem here. You can see this is 2 is alone. There's no y term here. Unless it is a mistake, you cannot solve this problem using the technique that we discuss here. Because when you write the lambda characteristic equation, you can write it because the 2, there's no y term here. So you cannot use the solution method that we discussed in this one to solve this one. So you can solve this using this method. So what we normally do, we're gonna write this one as y double prime minus y prime equal to, bring that to the other side, and then we use, so we need other methods. So we need other methods. So what we normally do, we use the undetermined coefficient method to solve this one. That's we discuss in another video with again some examples. So use the undetermined coefficient method. Use the undetermined coefficient method, or use the variation of parameters formula. Variation of parameters method. Okay, so this is the end of the review, and then we did 11 examples and with varying difficulty. I hope this can help you. Thank you very much.